welcome to the Data Science Festival. We're excited to bring you our Game On Spring Festival. My name's Kaylee, and I'll be your host this morning. Thank you all for coming and helping us to create such a thriving community. We ask that you switch your phones off to silent. A schedule of the talks and sessions is in your booklets, which can be found in your swag bags. If you have any questions, please find a member of the team wearing one of our staff t-shirts. There's also free water at the back of the room, so please help yourself. DSF is a celebration of all things data. We aim to connect tech community and foster a sharing of knowledge, inspiration, and ideas. Just a reminder that most of the talks will be recorded and uploaded to the DCF website and YouTube channel. If a room is full, please make your way to another one and you can watch back at any time. This event is free to attend and built by the community. Without the help of our sponsors, we couldn't make this event the success it is. Thank you to Data Idols, Key, StatsGig, dunnhumby, Zerva, Steam-Based, Ovo, Checkout.com, National Grid, Man Group, Founders 500, and finally CodeNode, who have provided such a great venue. Thank you again for attending DCF Game On, and we hope you have a great day. Check out the back of your booklets for the free popcorn, and have a read of our upcoming New Careers Day, and don't forget to enter the competition. Our first speaker today is Ali Parandeh from Applied Data Science Partners.
All right, thank you very much, Kaylee. All right, welcome everyone. Thank you all for coming here today for the first session this morning on fundamentals of building generative AI services. Today's talk, we're mostly going to be talking about what happens after you finish building a model. How can you actually put it into a product to actually start using it? How do you productionize AI models? Especially GenAI models like language models, image generation models, and so on, speech generation models. So my name is Ali Parandeh. I'm a head of engineering at Applied Data Science Partners. We do a lot of work with enterprises and companies putting these GenAI models into various products. And this session is essentially a combination of all the insights and all the experiences that I've gathered over the years building these kind of products. My background is coming from an engineering background, working for infrastructure companies, and then later on I joined rail tech startups building computer vision products. And recently, last 2 years, I've joined Applied Data Science Partners, building a lot of GenAI and LLM-based applications and putting them into productions, making sure they actually work, they're secure, they serve hundreds and thousands of users, they can process billions of tokens. And at the end of it, I recently also just finished publishing a book with O'Reilly. So I've got copies today that I'm hoping to give away at the end to one of the attendees who, by one of the questions, and also if you post on LinkedIn about this session with DSF Game On hashtag, I'll pick one at randomly. You can have a signed copy to take home today. So the session today is mostly going to have three main goals. One is about understanding the role of GenAI in the future applications and what kind of applications you can build with it. Learn how to productionize it. So once you build it, what are the steps that you need to consider when you go to the next parts, such as serving it, securing it, optimizing it, and all of those other areas. And also, lastly, what are the security considerations and ethical considerations you need to consider when you're actually putting these products into production, when you actually want to serve it to public users, to end users, and to hundreds and thousands of users. So the agenda into three parts. We're going to talk about building AI services, which is going to include what is GenAI, why is it used, what do you go from models to services, what do you need to do. Then we're going to talk about scaling them. So I'm going to talk a little bit about under the hoods in Python in relation to concurrency. How do you make these GenAI models process tokens in real time and give you tokens in real time? As well as how do we secure them with authentication authorization? How do you actually get around various different vulnerabilities that LLMs have and GenAI tools have, and how do you test it and deploy it into production? So these are the essentially three core parts of the agenda today. We're going to start with building, then we're going to talk about scaling and real time, and then lastly, we're going to talk about securing, testing, and deploying these AI services into production. So let's go to the first section and talk about building GenAI services. So what is GenAI? let's go back to the beginning. So GenAI essentially are models that have been trained on data so that you can generate new data from them, from the learned patterns and distributions that these models have learned from your existing data set. So they can generate samples based on, when you give them some sample noise, they can generate new samples that, it's not actually in the real data set, but it mimics and follows the patterns of that data. So like down there, for instance, is how a variational autoencoder works. It encodes the training data into some kind of latent space. Think of it as a mathematical abstract space that you can walk, and then you can, at whatever data point you land on after walking it, you can then decode it back into an actual generated sample. So generative AI models essentially are just models that learn the patterns in your data, and then you can use it to generate new samples that has not done before, but like within the constraints of your data set. The kind of applications you can do with these kind of models are actually quite vast, and there are different modalities. There is text, speech, audio, video, code, image. So there's a lot of different types of applications you can build. The way I think about it is the kind of use cases that are really relevant is being able to facilitate the creative process. So there are things that you cannot easily visualize yourself in the creative initial conceptual stages that image generators and video generators can really help you with, like open source, like Sora, for instance. You can personalize any kind of user experience now these days with them because they can just ingest in all of that textual data to give you personalized user experiences. You can automate manual administrative tasks, suggest contextually relevant solutions to users based on the inputs. You can minimize delay in resolving customer queries, so you can automate any kind of customer workflows with these kind of models. And if you're doing any kind of content generation, SEO, you can literally scale that content generation and improve the process, and not necessarily replace humans, but essentially improve and replace the boring parts of content generation with this type of models. But the thing is, building AI models and serving them and putting them into products is completely different beasts. So AI model is essentially just one component of actually building AI services, right? The other components that you need to have is you need to have servers that have routers that control the resources, that have different services like databases. You need to think about caching. You need to think about OAuth providers, authentication, authorization, security, file system storages that you need to talk to, the websites you need to talk to. If you're going to do RAG, retrieval augmented generation, you need to think about vector databases, backend databases for login. So it's a lot of different components. This is just one component of it. Whereas actually putting it into production, you need to actually put all of this together. You need to design all different pieces and think about the endpoints and the backend API structure and the architecture of that. So, for instance, an AI service could look like this. In like a code base could have a combination of models and repositories. So this is called the architecture of how you do backend services. You could have models, repositories. You have the client sending you requests. Then you have your GenAI models. There's a database. You might talk to other services, external systems like databases and email service. And essentially, there are various different concepts when you're building backend applications, in which case, like in how you process that data, like through pipes, through mappers, dependencies, controllers, and so on. So there's a lot of different concepts you may want to learn when it comes to actually building this kind of backend applications that this kind of onion architecture encapsulates. So as an example, putting these kind of AI services at the most basic examples into a service as with a web server is actually quite easy. My favorite web service is Fast API. I don't know how many people have heard of Fast API. Put your raise hand up. All right, a lot of people have heard of it. Yeah. So Fast API is now becoming the most popular backend web framework for building AI services. And literally with this few lines of code, you can load the model from Hugging Face. And Hugging Face has like 1.6 million models. Not all of them GenAI, but there is quite a lot of models. And all you have to do is install transformers for an LLM kind of models, and then basically select your model, put your prompt template in, and literally you have the whole model you can put into a Fast API endpoint. Right? So at the simplest form, you can create a server with an endpoint called /chat with just these 15 lines of code. But what's actually happening when you send requests to this server is you're having a relationship between the disk, CPU, and RAM. The model is being loaded on each request. So when you start the server, nothing's happening. But when you send it a request, the model is loaded into your RAM. Then the CPU uses the content from the RAM to load the model in and actually run the inference, and then it puts the model back onto the RAM. right? Once that operation is finished. And every request needs to do this. What this means is that once the request is processing, you cannot actually do anything. You cannot serve other requests. And that's a big bottleneck. We want to be able to serve multiple requests at the same time. And another kind of thing that we may want to do in Fast API is you can instead use something called a lifespan that's very specialized to Fast API, which is instead of loading the model on every request and then running the inference and then putting the model back, you can actually keep the model loaded all the time using lifespan events. So you load the model on the beginning using an async context manager, for instance. In the beginning, when the application starts, you load it into the RAM, and then just basically run the inferences every time a request comes in. That kind of speeds up the process if you're self-hosting models, but you still have the same problem of the fact that if multiple requests comes in, you still cannot actually respond to everyone because your CPU or your GPU is busy running it, right? Like this is the limit at the moment we have with this kind of self-hosting services. But it solves the problem with having to load the model and reload the model. So these models are massive. Imagine you're loading 15 gigabytes from your disk into RAM and then putting it back again. That will take some time, every request coming in. Whereas with this type of architecture, you can actually do it much quicker because it keeps it loaded. The only problem is that at the moment, basically you need a big RAM to keep it loaded and keep it running all the time. So how do we scale in that case? If basically adding, loading the model into RAMs, how can actually we scale this service and actually serve multiple people, multiple requests? Because you can't really put these models in products if you cannot serve hundreds and thousands of users at the same time. So essentially what this means is you need to think about concurrency. You need to understand what concurrency is in Python. You need to understand what parallelism is in Python. And these are two separate concepts. And the way Python does concurrency is very different from how C++ and Go does it. Right? So in Python, without concurrency, you just have your single CPU, and this CPU might process the requests and then basically sit idle until the next request, process that request, sit idle until the next request. So with no concurrency, this is how everything is working. When you do multi-threading, so Python has a feature called multi-threading. When you do multi-threading, a single process might create multiple threads, and you switch between them. Now, the way Python works is that you have something called a global interpreter lock. Has anyone heard of it before? GIL. In Python 3.12 and lower, we have something called GIL, which basically means if your process creates multiple threads and you're trying to do things on multiple threads, the lock will prevent you from actually running all the threads at the same time. You can switch between them to create the illusion of concurrency. That's exactly what Python is doing, but you cannot actually run them in parallel. If you actually want true parallelism, true concurrency, you need to actually run multiple processes to actually be able to run these tasks at the same time, serving multiple requests. What does that mean is that you need to run your server on 3 different workers, but you only have 1 RAM. How can you load 3 models at the same time into 1 RAM? Right? Imagine these models are a llama, like it's 40 gigabyte model. You're going to run out of GPU already. The good news is Python 3.13 is now experimentally removing the GIL. So that means that you can now do multi-threading, but it's still like something that is in the working, but something to keep an eye on. It's very exciting. So 3.13 is going to be removing the global interpreter lock quite quickly. The other thing as well is with single process multi-threading or single process single thread, normally these threads can share resources in a single process, but as soon as you go and try to do multiprocessing in Python, you're actually having to duplicate data, duplicate resources into the second. You cannot share them together. So whatever you do to the data on the first process, the second process will have a separate copy of it, a separate copy of its own. It doesn't necessarily know about anything about the second process unless you try to do something between them, and that's just going to create lots of complexity. So essentially, one of the first things we want to be able to do after we know about this kind of concurrency and issues in Python is the first thing we want to do is we want to be able to do batch requests. So if you have multiple requests coming in, well, how can we use the existing constraints that we have in Python to run multiple requests together? So one of the first ideas is called request batching. Fast API doesn't do it, but other services like BentoML and RayServe and VLLM, they do request batching to some extent. Without batching, you're basically waiting around. Every request comes in, you need to wait for it to finish before the next request comes in, you can process it. With static batching or request batching, you can batch these requests and then send them to the model at the same time. So instead of sending it straight away, if you receive multiple requests within the short time period, batch and send it to the model to fill your GPU as much as possible. That's essentially how you can actually get the most out of your GPU with something called static batching. So you can go from 1.2 seconds per request to 1.67 seconds per request, but your throughput increases by 1.25. Right? So you can actually process more tokens and process more requests at the same time with this kind of request batching. So some specialized framework allows you to do that. Their VLLM, or one of their specialized language model service, also allows you to go from static batching to something called the continuous batching. Right? So there are two separate types of batching you can do on this type of GPUs. With static batching, you're essentially trying to batch requests and send them to the model at the same time. But what happens if those requests aren't exactly maximizing the GPU? Right? What if these requests come at the wrong times and they don't have the right amount of, like, the prompt is short, it's not really requesting the model to do a lot of work. You will have a lot of gaps in your memory bandwidth. We call this VRAM that you have used. Continuous batching, what it does is actually it's quite clever. As requests are coming in, it actually tries to fit as many tokens as possible within the VRAM. So as the model is generating, the model is continuously generating, and all the basically the server, the VLLM server, tries to fill all the gaps with the input tokens and the output tokens of multiple requests. So it looks at each of the highways and see which highway to put the request in to fill the gaps in the VRAM. So you're actually maximizing the VRAM as much as possible. So these are like some of the essential things that you need to know if you're going to be self-hosting. Right? Obviously, self-hosting has its own kind of challenges. My own preference is to rely on LLM providers, OpenAI, Cloud, name it, Gemini, Google Gemini. So the main thing, though, is if you're going to be working with LLM providers, there is another type of concurrency you need to know about, async programming. Has anyone heard of async before? Anyone use async code? Yeah, in Python, there is a lot of gotchas working with async code. And not a lot of people are used to it, and not a lot of libraries support async. But essentially, the difference between normal code and async code is that with normal code, if you don't have any kind of asynchronicity going on, you send a request, you wait for it to finish, you send another request. So you're waiting between requests. Multi-threading, you're sending requests, and then you're switching between threads. And there is a kind of overhead to these, like request switching and all of this going on. Whereas with async programming, you're actually boom, 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 sending the requests really fast. And as you're sending the request, you go and do other stuff. So your CPU is not actually sitting around being idle at all. So what actually async programming does, there is a thing in async I/O called an event loop, which essentially is an orchestrator. It orchestrates tasks coming in and gives tickets out to the Python, and then essentially resumes and pauses operations based on what blocking input-output operations there are. In terms of looking at a single core, what it tries to do is fills these gaps with work. So if there are any kind of idle areas, what the async programming tries to do is it tries to fill the gaps between where the CPU is idle by filling any tasks coming in those areas, in those spaces where the CPU is being idle. So async programming at the moment, if you just try to use normal OpenAI client instead of the async OpenAI client, you will actually be 23 times slower in terms of throughput because of the fact that you're waiting around. Whereas like if you start using the event loop, you can actually do quite a lot. The only gotchas with this is you need to make sure the SDKs and the libraries that you use are actually async. So if you start mixing sync and async code together, you end up blocking the event loop, you end up blocking the server. So it's something that you need to study a bit more about before you start using it. It's a powerful tool, and it's a double-edged sword. The another thing you can do to actually improve your quality of your services is making your models real-time. Normally, the way the internet works is you send a request, you get a response back. We call this the HTTP request response model. So every server on the internet works like this. You have the HTTP sending requests, and then you're getting the response back. But there is more communication patterns than just a single HTTP request and response. You can do short polling. You can do long polling. You can use something called server sent events. You can use WebSockets. Have you heard of these kind of other communication patterns before? Yeah? So ChatGPT actually uses SSC. but ChatGPT Voice uses WebSockets, right? Whereas any other application on the internet that doesn't necessarily use GenAI, they may use request responses. You may also want to do short polling. So if you do any kind of batch processing API, you keep short polling the endpoints. What's with my batch job? What's the status of my job? What's the status of my job? Can I get my results back? That's short polling. Long polling is when you keep the connection open until the results come back. So if you have some expensive operation happening for a minute or two, and you just need to keep the connection open. But for AI and GenAI streams, especially if you're going to work with real-time LLMs, server sent events and WebSocket is protocols you need to learn. You need to be more familiar with. So here's an example of what a server sent event looks like. So you will see in your browser actions, this is essentially how your LLM is sending you the stream in words, in tokens. And essentially the way it works is that there is an HTTP handshake and there's an acknowledgement from the server, and then essentially there's a unidirectional message coming in from the server within the same HTTP protocol. And it's very simple. It's all the browsers support it, and there's an event source API in the browsers that allows you to do that. So knowing these web APIs will allow you to build really useful applications with this type of models. If you're going to be, so this is very unidirectional, so that's the most important part here. You cannot send back and forth messages. If you want to send back and forth messages, like having a chat, having a conversation, going back and forth all the time, you need to use WebSockets. And WebSockets is a completely different protocol. So you send an HTTP handshake. After the acknowledgement, the connection is upgraded to a WebSocket real-time live duplex communication connection. So it's open until one of the sides closes it. And you can go send packets back and forth. And there's a bunch of security considerations you need to consider. But in terms of like how the logs will look like, you can see that I've sent this "what is your name" OpenAI message when the stream is coming back from the OpenAI in terms of like back and forth messages. So yeah, normally with the WebSockets, which normally using duplex communication protocols, you will have the opening handshake, then there is a data transfer happening, then there is a closing handshake, and then that's where the TCP communication is terminated. So knowing about these protocols is really useful if you're going to be working with real-time systems. So if you want to make your GenAI systems, whether it's image generators or voice, speech, that kind of applications, you need to know about these kind of like protocols when it comes to building web services. The next thing that comes to the mind is security. So how do you secure these kind of services after you build them? So so far we've been building it, scaling it, but we can't just put it in the internet, on the public internet. You need to secure it. The first thing you may want to do is add authentication on the top, and there is various different types of methods you can use. There is basic authentication, which you shouldn't use in production at all. It's just for testing. Token-based authentication is most applications that do username and password that you use. So you send your username and password, they give you a token, and then you can basically access resources with that token. We call it access token. There is the OAuth. Now, this one is a big one, and a lot of people will have problems with this when they're trying to authenticate with Google or Microsoft or building SSO type of securities on top, because you need to understand how it works. It is way more complicated, but essentially you send authorization requests with your client ID, client secret, get a scope token back, grant code, you exchange that for an access token, then you can communicate with resource servers. And then if you're going to be using SSH keys and stuff, that's the last step, but these two are normally the most important models you need to think about if you're going to be building any kind of authentication and user management system into your apps. You also need to think about authorization models. So we have ABAC, RBAC, and REBAC, all of these names. So attribute-based access control at the lowest level, which allow at the finest grain control level, where you can, based on an attribute of the user, you can provide access. Relationship-based access control based on their group memberships, you can provide access. Like for instance, if you're in team A, you can access all of the models, otherwise you're not. And then roles-based access control is the most simplest, which is just basically on a role. Are you an admin? Are you an editor? Are you a viewer? Are you an anonymous user? And you just provide access based on that. So authorization is about who has permissions to do stuff, whereas authentication is about who are you, and are you allowed to access this application. So this is just the basics around just getting your app onto the internet. Then you need to think about if your GenAI model security. So we have misusers that have been categorized by several papers into these cases. So you have people who want to use your models for dishonesty, like to do plagiarism. You have people who want to create propaganda material with your systems, and then you have people who want to deceive others, like deep fake videos to like extract money out from other companies. So like Arab, for instance, got scammed out of how much? 25 million pounds just using deep fake videos. So you need to be aware of this because it creates legal problems for you if you're going to be using this into production. And you also need to be wary of the top 10 LLM vulnerabilities that OWASP has published. So it's like an open foundation group that looks at security. Like there is prompt injection, you have insecure output handling from the LLMs. They can poison your training data if you have access to it. There is model denial of service. So if you send too many requests to your service. You could have sensitive information leakage. You can have excessive agency. So if you're building AI agents and your agents have access to payment systems, I could literally hack that so that I get paid quite a lot more. So excessive agency, over-reliance on LLM and model theft. So these are the kind of things that might be happening. So there was a whole discussion about did DeepSeek did model theft on OpenAI models. So all of these different things that you need to consider when you're working with LLMs and their vulnerabilities around that. You can use input-output guardrails as the first instance of security for these. So input-output guardrails are essentially perhaps classical AI models, classical machine learning models, or perhaps the LLM itself performing self-checks on the inputs coming in and on the outputs going out. And you can have different validators on these checks. It's very modular. An example of the code there is basically sending two multiple async requests to the LLM provider. As soon as one of them rejects, you reject the whole actual request. But because it's done in parallel, the user doesn't feel that there is any kind of like latency because of that. So input-output guardrails is something you do need to consider if you're going to be providing your model and releasing your model to the public. So this is taken from the OpenAI cookbook, if you want to have access to that code. Right. After security, you need to think about optimization. So there are things called semantic caching and prompt caching and context caching. How can you use as much token as possible? So some LLM providers allow you to do context caching. So if you're going to keep sending the same prompt, they will cache the prompt so you don't end up paying for it. So if you have massive prompts sending in, 20K prompts and stuff, they will cache the prompt for you, costs you less, and less processing for the model to do. If you're going to be doing any kind of RAG services, you can do semantic caching, which only fetch the data from the vector database once and cache it based on the input prompt. So if they just change a piece of the language in the prompt, you keep serving the same content, especially for FAQ type RAG applications, which the answer remains mostly the same. You don't want to keep going back and forth between the database. And you can even visualize the graph based on some semantic threshold. So it uses just semantic similarity scores to do this. Other things you can do if you're self-hosting is quantization, which is essentially trying to squish down floating point numbers like decimals into integer-based numbers. That will reduce quite a lot of memory bandwidth that you use in your models in your VRAM. So your neural network might go from this to this. And like the kind of savings you can do is a Llama 70B model could go from 140 gig to a 28 gig model. Or if you have a 16 gig model, you can have a 3 gig model just by quantizing it. And the accuracy trade-off isn't that bad. You can still work with it, especially if you're going to be using it as a classifier system or any kind of like narrow use case type applications instead of general wide use case type applications. And then when it comes to testing, it's very hard to test GenAI because obviously all of you know these are probabilistic models. They have their own challenges. You have performance and resource constraints. Keep sending test requests every time that you run your CI/CD pipeline to these models. It's expensive and slow. The variability of outputs and flakiness of these models could cause problems with your unit tests or integration tests. Your models could regress. So if you change from GPT-4 or Preview 1 to Preview 2, you need to make sure that it doesn't actually become worse. And GPT models have shown to become sometimes worse. There are some other talks that go into that detail a bit more. Bias is another thing that you need to consider and you need to test for it. Adversarial attacks. Can I do prompt injection? Test for it. You can test that. And unbound testing coverage. These are like different challenges. Like you don't know what you need to test with GenAI. How can you test OpenAI model? So many things you can ask it. There are so many use cases. And You need to also think about your integration test, how you plan the boundaries, like what are you going to exactly test. All of these are like different challenges when it comes to planning test suites for this type of applications. One framework that I came across that is really good is the checklist framework. And this one essentially uses 3 types of tests. Minimum functionality test, which is basically the core functional tests that you need your system to perform. So if you switch the text, will it actually work how you expect it? Invariance test, which basically means if you switch something simple, something very small, would it completely change the results that you expect? It shouldn't. So that's why it's called invariance. You don't expect any variance happening if you switch just a single word in your prompt. And then you have directional expectation test. It's like correlation tests. If you increase A, do you expect B to increase or not? You should. If B doesn't increase with the other one, if it doesn't increase in the same direction, you know that test isn't actually passing. So in here, for instance, you just add a single sentence at the end, and you don't expect the output to change by this. So definitely that checklist framework is a really good framework to have a look at and be able to go with it. Lastly, when it comes to deployment, my own preference is Docker. Does anyone use Docker here? Yeah, nice. Quite a lot of people use Docker. If you don't know Docker, definitely learn it. It will make you a better data scientist. It would make you a better engineer. And pretty much all cloud services, depending on where you are, you can actually deploy these Docker services to, you can containerize your application to work in anywhere at a very small amount of footprint in terms of memory, disk, RAM. And there are obviously challenges around how do you put open source models into these containers. But yeah, essentially the core architecture of Docker is that you create your containers using the client. You can send some requests to the Docker host server, and then once you create these containers, you can put them into registry like Git. Think of Docker registry like a Git code base. You can commit these containers to the code base, version control them, and essentially deploy them on any cloud in any environment. They don't need any OS to themselves. They basically run on something called a hypervisor of themselves. So it's much easier and much faster to work with once you containerize these applications. So if you're not using Docker, definitely start doing, and hopefully that should help you get moving much faster. So all of these topics that I just talked about, basically comes from all of these concepts are based on my book that just recently came out. So we have 3 separate sections in the book. One section talks about what GenAI is, how do you start with getting started with fast API server, add these models add different variety of different models into these servers, make sure that your whole service is type safe. Section 2 goes into achieving concurrency and learning more about concurrency, then learning more about real-time communications and these protocols that we just talked about, integrating them into databases, and then the last part was about authentication, authorization, security, optimization, testing, and deployment. So if you haven't already, feel free to post messages on the LinkedIn. I will be monitoring them and then I will be giving away a copy randomly to a message on DSF Game On. And also, yeah, if anyone have any questions, I think we've got about 8 to 5 minutes that I'm happy to answer questions.
You mentioned about bias in testing.
Yeah.
What is the approach taken to find the right bias, like whether it's a data shift biasness, or is it application biasness, or is it a model biasness?
So data bias, application bias, and model bias, right? So if you're building your own models and you have access to data, there's definitely various different exploratory data analysis you can do on the data itself to catch the bias and make sure that the bias is correct. On the model itself, if you're downloading an open source model, I would essentially go first with doing some research around if others have already done any kind of conducting on that research on that model first. If not, and you need to do that research yourself, then obviously you can use the checklist framework to some extent to check if there is any kind of bias. But it's normally very hard with these black boxes to detect them. But there are essentially techniques that you may be able to find in research papers to follow them. And then essentially on the application bias is you may need to do end-to-end testing and integration testing. So you need to define these tests, define the boundaries, and end-to-end tests, there are 2 types, horizontal and vertical. So vertical testing is you define different cross-sections of your system and you test that. End-to-end testing is you define a user workflow and you test the whole workflow. And you define them, and then you can essentially implement them with different frameworks like PyTest, and just have different variations testing the boundaries of the data points, like the bad inputs, good inputs, invalid inputs and out of range inputs. You can test them with these different areas. Thank you very much. Yeah.
Thank you for giving a comprehensive
No
overview
worries.
how to embed in an enterprise an AI service. Do you know, or can you tell about the costs in a large scale, how it will change?
So if you're going to be doing like billions of tokens of processing, let's say you're a mortgage broker or you're a financial firm and you need to process millions and millions of documents, what you can do is instead of sending the request to the same normal API, most LLM providers these days will have actually batch processing APIs. What these processing APIs do is something similar to what I talked about, the continuous batching and request batching. They actually save you a lot of tokens because they will try to cache inputs, outputs. They will try to optimize it, but that means that you will get delayed response. So you need to come back in 24 hours. You cannot get your response immediately, and also there is quotas you need to work with. But in terms of cost, instead of spending $400 on one batch, you can spend $100 just using the batch API. And it's a separate deployment that you need to deploy, for instance, if you're deploying it on Azure OpenAI.
Hi, thank you very much for your talk. Lots of great detail. Can that detail sometimes make it difficult to be flexible and agile in terms of moving and changing? So, for instance, you described lots of parts of the system that have to be implemented, very important parts. And there's going to be a lot of time and money invested in delivering those parts. How would a business determine when is the right time to jump ship? Change model might be quite easy, change framework might be more difficult, and as we go down the line, we're going to have more money invested, but maybe the returns are high. How would I know when it is time to move?
To a different model, you mean? Or
not
to
necessarily just the model, but you described different approaches in terms of the Python program, for instance. So there's all sorts of different stages at which you might want to change. In your experience, when would you start doing things in a different way in order to realize the benefits?
Yeah, that makes sense.
Sorry.
No, that's a really good question. I think that the best thing you can do is you need to do requirements planning. So the same software engineering principles applies to these kind of tools as well. So the more you plan at the beginning, the 10 hours that you spent will save you 100 hours later on. And I would say when you're first starting, don't worry about all of these other productionization steps. Build a simple solution without authentication, without security. Just build a simpler solution that you can use and just does your functional requirements. And then later on, once you feel like your requirements are a bit more stabilized and you don't need to keep switching things, and you've tried and tested everything, that's when you go and add all the productionization steps on top. Because as soon as you add those additional layers, you're adding layers of complexity, like deployments and testing, and tests could be brittle. Like end-to-end tests are very brittle. As soon as you switch something, everything breaks. You need to fix your tests, and it's better you add them really at the later stages where you feel like your requirements aren't going to as much change. It's like constructing a bridge. At the beginning stage, it's much easier to change the bridge design. But once you finish the bridge, it's very hard to go and change the materials of like the legs of the bridge. So don't build a bridge yet. Build like mock-ups and build simple solutions. And then once you have stabilized the requirements a bit more, then go and completely switch the play around with the changes. All right.
Thanks for the talk. I think you covered a lot of stuff. I'm over here if you're looking. You covered a lot of gotchas for us to follow, and I think I follow his question as well. I've got a couple of questions. One is, I'm a great fan of JobLib, if you've heard of JobLib.
JobLib.
It's like
it's a ML4 similar?
It's a parallel processing system in Python. And I feel that you could go to market faster with JobLib than async.io based solutions, although I think async.io based solutions may be faster. But what do you think is happening under the hood? It is doing multiple processes.
JobLib probably does multiple
processes. Because I didn't see that in one of your slides, because there is that aspect as well, where it's not doing one of those other combinations you're doing where you're doing single processing and just giving you illusion that it's switching between tasks and making it faster.
I think with multiple processing, my only worry would be to make sure it doesn't duplicate resources.
Oh yes, of course. Yeah. So race conditions aren't a solution for multiple processes. You need to isolate them all the way. So storage and memory and GPU memory, they all have to be isolated.
But yeah, like I think in terms of like increasing the parallelism, it's really good in terms of if it creates multiple processes. I would prefer that in terms of async.
Yeah.
The only thing async solves is input-output bound operations. Joblib could also solve compute-bound operations rather than just input-output bound. So you go and start using multiple cores if you have compute-bound operations that are blocking your service. Okay. So if you're serving models, it blocks one of your CPUs. You need another CPU to handle other requests, and that's I think Joblib and this kind of.
Yeah, I see the boundary there. I was just trying to confirm if that was
async solves input-output.
Yeah.
So working with file systems, working with the web, working with database. Anytime you need to send a request and wait for it.
Yeah. Because
ticket-based systems. Yeah.
Correct. My other question was, you had this section of the slide where you categorized misuse. Can you go to that slide?
This one.
Yeah.
This one?
Yeah, that one. Now, the next slide that you go to, which has got the LLM vulnerabilities, where do those actors that use this to attack your system fall in the previous? Because they are misused as well, right? If you
No. So the prompt injection, for instance, or prompt overrides.
But also, I'm talking about the actors that will come and try to steal data from your system. How is that categorized here?
So this is more like abuse.
Destabilize.
This is more like the misuse and abuse. That one is more like security attacks. So the categorizations in here may not necessarily overlap with the next set with the next table. Next table is about completely attacking your system and shutting it down. This one is about using your system for malicious intents.
Okay.
Like, I don't know, I want to scam one person, I may use your system to scam them. Like maybe you're Suno AI, you generate audio, I want to scam someone else, so I create my own voice, or I create the CEO's voice and I scam them by making a phone call.
But that actor overlaps with the next actor as well, because they have to sometimes use malicious ways to get into your system to do that,
Yeah.
right?
Yeah.
So I think there is a bit of an overlap here, but it's just discussion.
It's just a discussion. All right. I think that's pretty much all the questions we have time for.
Yeah, thank you so much. I'm afraid we're out of time, but thank you so much, Ali.
Thank you very much.
We're just taking a break now. Please help yourself to coffee.
Cheers. Thank you. I'll give them to you.
Thank you very much.
Yeah, no worries.